What's up guys, Shawnthebro here, and today we're going to be going over something very fun and interesting to me, and hopefully it will be to you too. Charge attacks and charge movements. So basically what a charge attack, or like this charge character concept is in a fighting game, is a character where you hold one direction to perform an attack. You may need to hold it for, some people say a second. We're going to cover it in a number of frames, but it could easily be converted to an amount of time if that's what you'd prefer. There is a lot that actually goes into this when making it work with our current input buffer system and our input windows, and there's going to be things that we're going to have to cover at other points regarding this because our input buffer system is going to continue to update and change as our game progresses. To get started, what we really are going to do here is you can see a few things printing in the top left of the screen, and those are just print strings that I have that tell you how many frames you've held down a button. So you can see it actually fires when you press it and when you release it. So you can see it starts at 0 when I press it, and I'm holding it down. I held that for 314 frames. Now, you won't ever need to charge an attack that takes that long, at least not that I've ever seen, but you could if you wanted to. And so what I've done is I've tracked how long buttons have been held down. And then based on that, if a button or an input has been held down for a long enough period of time, then it gets tracked and stored with the input that goes into our input buffer. And then if that is higher than the value required to charge an attack, then it will know that it was a successful input. So in my specific case, I changed the homing thunderball, that's what I've called it, projectile, to work based off of if I've done a backward charge input for 30 frames, and then done my regular other input. So usually I have to do back, forward, special. Back, forward, and special. You can see it didn't fire. That's because I didn't execute quickly enough. So let's execute it more quickly. It also didn't fire. And that's because this is a charge attack. So I need to charge my backward movement, or hold my backward button for 30 frames. So let's do that. Make sure that the number that prints is 30 while I do it. And you can see I held it for 36 frames. And there we go. I was doing some changes with the homing Thunderball's hitbox, and that's why it phased through the player. But you can see here that I held it for 36 frames, and I performed the inputs, and it worked. Now, if I were to, again, just perform it out of the blue, that's only 5 frames. It's not long enough. And there's 39 frames, and it's long enough, so we perform the attack. Now, there's a few things that we will need to fix in the future. However, they are going to be fixed in the next episode that we do on this topic. So specifically what we need to cover is, you noticed how when we did the charge attack that 2 of the homing thunderballs came out. So this is actually something that's occurring because of the way our input buffer system is set up. And it can easily be fixed, but it will require basically the logic that we're going to use for the multiple buttons at one time fix. And so what this means is we will need to update our logic so that once an attack fires off, even if it's stored in the input buffer, it cannot fire again. And this is something we are going to be updating already. It's already part of the input buffer system, but you can see now that we definitely need it for these charge attacks. So look out for that episode. We'll be covering that, and I'll go over what you can do for now to just avoid that, ignore it. Before we actually get started on the logic that we need to add, if you would like, here in the top right corner of this video is the playlist to the fighting game tutorial series. I believe this is episode 94, 95, so we are really far along, and we still have way farther to go. But if you want to catch up and see kind of how we set everything up to this point and how we got to where we did, then there's the playlist. You can check up on all the progress that we've made. Otherwise, I'll leave this icon in the top right corner right here to the input buffer episode, the part 1 episode of that little mini series within the fighting game tutorial. that'll lead you to at least everything you need today. All right. So a lot of what we're going to be doing is in the code today. So let's go into our fighter template character.h file and let's take a look at everything that we have in here regarding the input buffers that may need to be adjusted for charging. First things first, in our, at the top of our file where we have all of our structures, we have this F command input structure. And F command input is basically the input that needs to be pressed to perform a command. So, for example, if I have, 3 inputs that I need to press to perform this homing thunderball, then I need to have, this input type, so backward, this input type forward, and then this input type special. And that's what we had prior. It's very simple system. And we did include this input status structure as well that I added during the press, hold, and release button types. If I could find that right here. We have none, press, release, and hold, these input statuses that we set up. They're finally going to come into play. So we put that in there as well. So it's a button, and then if it's a press, release, or hold input. But now I'm adding something else, and I'm adding the required charge frames. I made an integer 64 because frames in Unreal Engine are considered int 64s. However, a regular integer is actually probably better because that's all that is really needed here. I've just done this so that we can do things like print out the number of frames without converting the integer to an int 64. You can easily keep this an integer. Again, you don't need int 64. You can just use int. I'm just doing this so that I can easily convert from Unreal's frames to our tracker for them. Okay, and basically this is how many frames an input needs to be held down to successfully perform it, or for it to be considered a successful action. So when we're reading through the our circular input buffer, we want to make sure that if we have to charge this attack and we have to charge it for 12 frames, then we want to make sure that's how many frames we put in on that command, on that input. That way we know if that attack has not been charged, even if the user has pressed the correct inputs, if they've not charged that attack, then it should not actually perform that command. I had done that on the specific input as opposed to the command, just in case you want to throw in individual inputs within the command that have charged values. So you might not always have it at the start of your command. I'm pretty sure the standard is to have it at the start. That's where I've usually seen it. However, I know that it is possible to kind of combine charged inputs in other commands. So if you would like to put it somewhere, so say you have backward and then you have to charge your forward movement and then press punch, you could do that using this method. You can put the required charge frames on the individual sections here. All right, and then let's go to our F command structure. So on here, everything is pretty much the same. We don't have to change anything specific to this since we have the required charge frames here in the F command input. But make sure that this max frames between inputs, just be aware of this. We default this to 12. This means that there are 12 frames where all of the inputs in this command have to be performed to actually successfully perform the command. So to perform the homing thunderball, I have to do all those inputs within 12 frames by default. I actually end up adjusting this so that I have a little bit more freedom and different things like that, and I can perform them more easily. However, you can make this value whatever you'd like. You can make it larger. You can actually completely ignore this for charge attacks. Like, there's a lot of ways we can handle it. So I'm going to leave this alone for now, but just know that that is there in case you want to adjust it. Okay, let's go down to our F input info structure. I know there's a lot of structures, but this is also important. So F input info is a structure for all of the inputs that the player presses. This is not tied to the command. It's just the raw inputs that the user is giving the game, or giving the character really in this case. So before we had the input type, so the actual input itself, the input status, so if it's press, hold, release, the frame that it was pressed on, which is used for things like determining if these inputs were pressed within a quick enough time to perform the command. But now I've also added something else called charged frames. So I decided not to separate the F input info from the charged input info. So that every input, whether it's charged or not, does go, it's just a regular struct of F input info. But this charge frames value can go from 0, as it would normally be if you just pressed it one frame and released it, or it can go to a higher value if you're holding the input and it's getting higher than, if you're holding it for many, many frames, it will keep track of that and then store it when we go into our circular input buffer so that it will know how many frames that input was held. Lastly, I do have an F charge input structure that I've added now. So you can add this whole thing. And what this is it's a structure to store all of the inputs that are charge values. So this doesn't really keep track of input values and things like that. What it actually does is it determines which types, so which inputs can be charged. So in this case, I will have backward, forward, and crouch most likely will be the 3 that I use, but you could use it for anything. You could actually use it for like a light attack. So say you're holding the light attack. As you hold it, either you go into a charged version of that attack, or maybe you actually slow down your animation and do more damage. However you want to set it up, you could do it using this method as well, but I'm not going to be covering that today. And so charge input, I'm going to have the input type. This is basically just the enum that we have that stores each button. So if I scroll up to that structure, I know we have a lot. So to make things a little bit more clear, the input type is the basically the action that the button the player presses corresponds to in the game. So if they press, right on their analog stick and it correlates to forward, moving the character forward, then that's the input type that we're referring to here. Then I have this U property, ChargeFrames is what I call it. Doesn't really matter what you call it. Just know this is how many frames this input is currently charged. So you're probably asking, why are you doing it here and here? So here's the difference. F input info has a charged frames integer because of the fact that the F input info structure is what gets added to the input buffer. And so we want to have the number of frames that an input has been charged so we can check against it when we're using a command or any sort of attack that requires a specific number of frames charged before using it. However, this F charge input structure, although it looks similar to our F input info, it's different because it's going to track if we're currently holding an input or not. And then if we are holding it, it's going to increment the number of frames that are being charged. And if we're not, it's going to stop incrementing it, set it in the F input info structure for that input, and add that to the input buffer. So these are really the same thing. They probably should both be called the same thing for convenience. I'll go ahead and update mine. And then this Boolean is holding input, which I default to false, is there to determine if the user is still holding this and we should still be incrementing that number of charge frames. All right, so there's a lot going on there. There's a lot of changes to these structures, but this is a pretty complicated topic since we are also handling everything else that we already have in the game and trying to make sure that nothing breaks when using these charge frames. So we have to be very careful, and thus there's a lot that we're doing with it. I do have some other stuff commented out here that you may see. This is actually for the next part of the input buffer that I was talking about that would fix some of those issues that popped up earlier. But we're not ready to do all that yet. There's quite a bit in those, in that section that we're going to have to cover. So I'm breaking it up the best I can. Okay. If you scroll down to where you have your functions, we have a function called check input buffer for command using type. Or if you overwrote it at the time of watching the episode. Yours might just be called check input buffer for command, either way. But basically, the one we want is we want to have our function that checks the actual enum value of the action that we talked about earlier, that e input type. Then we're going to add two new ones. So I'm going to add one to start tracking the charge time and to reset the charge time. Both of these are important because one is going to start tracking the time that an input is being charged, and the other is going to reset it back to 0. So once we either release the input and we're done with it, we can set it back to 0. Or if we press another input and we no longer need to keep track of that charged input, we can also reset it. Something good you could do here would be use a reference or a pointer to the structure. I'm actually going to avoid that today and just pass a copy of the structure in. So not the best for performance. It would be a little bit worse than the reference or pointer. However, the benefit here is that Unreal itself actually has a few bugs with the structure where it doesn't quite track it properly when you try and pass in a structure as a parameter and make it visible to Blueprint. You will actually not be able to edit everything that you need to be able to. So for now, I'm opting to ignore it. That way we don't have to worry about, we already have a lot going on this episode, so we'll ignore that for now. We can always update it later. But pass in an fcharge input structure, and I've called them input to track and input to reset, but the name doesn't matter. That's just for you. All right. And there's one other thing we need to do. We need to add an array of these charged inputs as well. So I've called it tarray fcharge input charge times. You could call it charge inputs, whatever. There's just a lot of the same word being thrown around of input there, and I don't want to make this more confusing than it needs to be. So I've called it charge times, but know that it's an array of our structure for our fcharge input. Okay. And at this point, everything else is stuff you have seen before, so nothing you need to worry about. Let's go back up to the top, and we could go to the CPP file. Start talking about everything that's changed in there. So I'm scrolling down all the way to my input buffer logic. All right. So I have this add input to input buffer function. And this function is basically when we press an input, it gets read by Unreal. The input gets captured by one of its events, and it gets converted to what the action will be in game, that little enum value, and makes an f input info with that data. Remember, f input info has the input type, has the input status, has the frame it was pressed on, and now it has the amount of frames it was charged. And so it takes that, and it is going to use that data to store it in the circular input buffer. Now, this actually isn't changing at all. However, it does call check input buffer for command using type at the bottom of it, and that's mainly where we're going to be making our changes today. This is going to be where almost all of our charge logic comes into play. So if you go into that function, check input buffer for command using type, you can see it's a little bit different than it was the last time. I've added a few things. We've moved a few things around. So first things first, it's the same logic where we have a correct sequence counter. We basically have the number that we've gotten correct, the number of inputs in a row to perform a command. And as we loop through each possible command and check the inputs against the inputs in the input buffer, this correct sequence counter resets. But now, for each command, we need to check and see an additional parameter. We need to see if the inputs that the user or the player is inputting are being held and charged. And then we need to compare it against the values that should be held or charged and for how long for that specific command. So this stuff is all the same. Everything you see here is the same. We did support these things in the past, But make sure that you have this E input status. We haven't really been using it to date because we haven't had a reason for release or hold inputs. We've only been using presses. But in this case, I'm going to be using a release input. So I do need to make sure that the status is accurate. Then I've also added a local variable here, once again called ChargeFrames, just to capture this. You don't have to make variables for these. You can literally just grab, that, and that if you'd like. These are just local variables. They get cleaned up once the function is complete, so it's not a huge deal to make them. And it makes our lives easier to compare against type, status, and ChargeFrames. All right, but this new variable int64 ChargeFrames is grabbing the circular input buffer at the frame we are looking at and grabbing the ChargeFrames variable from it. Very, very simple. Now, here's where things get a little bit more confusing and a little bit more complicated. So let's try and walk through this one step at a time. Before, in this if statement, all we were doing was checking the type of the input to make sure that it matched up with the type of the command that is expected if we're performing that command. So for example, again, if we do backward, forward, heavy, if that is our, I think it was actually backward, forward, special is our homing thunderball. Then it checks if the user has pressed backward, forward, and special without making any mistakes along the way. Now, that is good. We still want to keep that, but there's more things in play now. So I don't just care about if I've pressed the correct inputs. I need to know how long these inputs were held. And so if an input has not been held for enough time and it is a charge command, it needs to be charged at one or more of the inputs, then we don't want to perform that even if we press the right actions. The other thing is we were only considering pressed inputs at the time because we were only calling this function when an input was added to the buffer, which was when it was pressed. We never added them when they were released. We will need to keep track of when users are pressing and releasing inputs because it will help for A, the multi-button inputs, and B, the charge attacks like we're doing here. So for our status, we need to make sure that the status that we grab here, again, we did cover this in the press hold release episode, but we never did anything with it. So the status, we need to make sure that it lines up with the status that we expect on our current command. And let me show you what that looks like. In the mutant BP, if you go to your class defaults, so if you go to your character and your class defaults, I'm going specifically to my mutant in this case. You could do it on the base character. However, you really want to do this wherever you have specific commands. And the base character should not have any. It's more of a wrapper class. So let's scroll down and let's go to our homing thunderball and open it up. Whatever attack you want to use charge attacks for is fine. Okay. So I'm going to homing thunderball and I'll move this over so you can see everything. Whoops. Not exactly what I was trying to do there. Undo that. Go back into it. All right, let's move this over. So here it is, 9 to 10. All this is related to the homing thunderball, everything you see here. So we have the inputs of backward, and this was press before, forward press, and then special attack press. You can see I've changed it a little bit. What I'm doing now is I'm actually putting backward as a release type. You could do hold, but really all I care about, since it is the first input in the command, is when it was released. I just want to make sure that input was held prior, but when it's released is when I can start capturing it. So what I actually do is add a change backward from press to a release type. And then the required charge frames, instead of being 0, I put to 30, meaning I need to perform this action for at least 30 frames. When this release gets called, if it's higher than 30 frames, then we'll know that we've succeeded in charging this attack. Then I have to do press forward, release forward, and press special attack to perform this command. Now, I've added this release forward in here. And that's because right here, I have this else statement that will reset our correct sequence counter if we perform the wrong action. Well, now that we actually care about the status because we need to know if we're pressing, releasing, holding, then it will actually be considered wrong to release something like the forward button. And then what will happen is it will say, oh, you haven't completed the command correctly, even though we actually have. So we have two options here, and I will be covering them both. Today I'm actually going to go the lazier route because we're going to be exploring the other route in full. We have to for the logic required in that episode. For the episode regarding multiple inputs in the same frame or within, very, very quick succession of each other, such as, like light and mid to perform a throw or something like that. So we're going to be covering the bigger picture and the really the correct fix for this section in that episode. But again, it's too much to cover right now with everything we're already worrying about. So the alternative now, the quick method now, and you could actually keep this, it won't really hurt anything, but what it requires is if you want to still perform all your commands that you have set up, then your solution here is anytime you have a press, if you want the user to release that input before pressing the next one to perform their command, so backward, forward, special attack in this case, make sure after a press you have a release. You don't need a press for the first one if it's a charge attack, and you don't need the release after the second one if it is, after the last one if it is a regular press attack, because you don't need to actually release it for the attack to go off. It should go off as soon as the user presses the button. So I have backward release. If it was charged for 30 frames, go to the next one, and we'll go, if it was a forward, then release forward, and then press special attack. And that's how I perform homing Thunderbolt. So now when we go back into this, you can see the status has to be equal to the status that we've given it in there, in that character BP where the command was. And the number of charged frames. Yes, this is separated on two lines. You don't normally see this from me. I don't like to do that necessarily. However, this line is getting very long. And so this if statement, you can enter at any point just so you're aware and break things up and make it look nicer. This is completely valid. This is still all one if statement. Code does not care about white space, they call it, or like empty space. So basically, anything that you have without symbols going on. So like you see how this line ends here? Well, I don't have like a closed parenthesis or anything here. So the compiler is going to read to this, and then go to the next part instantly. It cares more about the symbols that it sees and the keywords than it does space. So you can clean this up as much as you'd like. You could even do it like this if you wanted. And some people will. So basically, you can see the type has to line up, the status has to line up, and then the charge frames have to be greater than or equal to the required charge frames for that input. The greater than or equal to is really key here. It's good, of course, it's got to be greater than, if it's greater than, that's fine. But it should also be equal to, because if it requires 30 charged frames, and I hit frame 30, I do want that to trigger. The other really important part about being equal to is that for all the attacks that aren't charge attacks, if they're 0, well, charge frames defaults to 0. So it will be equal, and it will automatically let that pass. You don't have to worry about doing anything additional to account for that. And then in that if statement, I just subtract from the correct sequence counter, which we were already doing. Else, if the type is not equal to none, we performed an incorrect input, so we reset the correct sequence counter. This is what I was telling you about earlier, and this will tie into the next episode that goes deeper into this stuff. But the alternative to putting a release after every press is to, essentially, we will ignore release inputs as being able to mark things incorrectly. So we won't be able to get this wrong. We won't be able to, not perform this command because we released an input. And I'll show you how that looks and why that is honestly the way to go, the better way. And it's also less work for us, so that's excellent news. We'll get more into that in a little bit here when we finish going over the system. Then if the correct sequence counter is equal to -1, that means that we've matched all the inputs we needed to, and we can then add that move to the buffer and there's more logic there. That we have a lot in there, but it's stuff we've already covered, and I didn't have to update any of it for the charger text, so I'm just ignoring it for now. All right, now let's write our charge functions. So we need one to start tracking the charge time and one to reset the charge time. They're pretty simple functions if you write this out. I just do a for loop because since we're not using a reference or a pointer for the reasons I mentioned earlier, we do need to make sure that we make these changes on the applicable object. We don't want to try and do it on this structure. This structure is just a copy. Changing values on that structure won't actually solve anything, but we can retrieve the data, making sure that it is the correct value, and then we can actually use that to change the values on the actual object that we have. And so what I really mean by that is if you go to class defaults yet again, we'll make them together. So if we go up to our charge times here in our character, I'll do it in the mutant just to show you that it is probably the right way we should do it. And I can go to my inputs that I want to track. This is important because we don't necessarily want to track all of our inputs. If I know no moves care about charging the light attack, then there's no reason I should be tracking it, incrementing it, or anything like that. However, I do know that the forward, backward, and let's say crouch inputs should be able to be charged, should be kept track of by the system. Then I'm going to put those three into the charge times. Any inputs not in the charge times array here won't be tracked for if they're being held. So again, if you don't need them for any sort of charge attack or anything like that, then I would just completely ignore them in this charge times array. It can be completely empty if your character is not a charged character. I'll keep it open so you can see it actually, but there you go. Now, when I go in here, what we do is we loop through all of them. This is a standard for loop to loop through all of the elements in there. I have 3 elements in there currently: forward, backward, and crouch. We're going to loop through and we're going to check the input type and compare it to the input type of the structure being passed in. So remember, this is a copy. Our input type is the enum, like forward, backward, crouch, like we just set up. And so we want to see if this charge time is equal to the structure's input type that we're passing in to start tracking charge time. I know we haven't called this function yet, but this is going to be used so that when an input is pressed, we know that we want to start tracking it because it is essentially worthy of being used for some sort of charge attack or some sort of command where we need to know how long the button or the input has been held. And so if it is the same type, if this loop element that we're on is the same type as the input being passed in, we know that this input is currently being held. So I set that actual element in this charge times array to be true. We are holding the input. All right, now make the reset charge time function. You can do the same for loop. You do the same check, make sure we are on the right input. We don't want to change inputs that are not ours or not correct for this situation. We do the opposite. We want to reset is holding input to be false. Basically, the user has released this input. They're not holding it. We don't need to keep track of it anymore. But also, charge times, the charge frames, of that element needs to be reset to 0. At this point, they're no longer holding it. So not only do we not want to increment it anymore, we don't want to update it anymore, but we also don't want to leave the old value in there. If we leave the old value in there, then I could press it next time and it would say, oh, yep, you charged it for 30 frames, and I could perform the attack more quickly than expected. So instead, I'm going to reset my charge frames back to 0. All right, let's go to tick. So for tick, we did make a minor change here for a mistake that I actually realized I had made. It didn't really hurt anything because the logic itself still did function properly. However, it would technically lose 1 frame off of the circular input buffer, and so under some weird cases, it could actually cause an issue. Let's fix it up. So before we were doing this, if curtick is less than 59, increment it, otherwise reset it to 0, and we use this for a circular input buffer. However, we were doing this at the top of this tick function, whereas we were actually using curtick here. So if we increment it, this value would actually be incorrect. And so it's better to move this logic here. I didn't change anything for it, so you don't have to worry about that. But take this value here, or this logic here, and put it up at the top of tick. Move the incrementing of tick, or the setting it back to 0 of tick after it. And we're actually going to add this in as well before that logic. So just a little bit of a timing issue. Again, it didn't really cause any problems. I can't imagine that it would. But under some certain circumstances, it could, depending on how it gets used. And I figure we should just fix it now. Okay, so what we actually want to do here is update all of the charge time. So any inputs that are held down should be updated for the, each frame. That way we know every frame this value should be updated, stuff like that. And so all I do is, in this case, I actually loop through charge times, check any that are currently holding the input. So any of the inputs that the user is currently holding. So if they're holding crouch and back, then they will both increment here, which is intended. So I check if is holding input is true. And then if so, I plus the charge frames, which means I just increment it. So every single frame that input is held down, number of frames being charged increases. One additional thing you could do is here where we're setting up our kind of fake F input info for a none. You could reset this value if you'd like for the charged frames now that we have it in there. I like to do it because of the fact that it's just more consistent. However, it's definitely not necessary. It won't affect anything. It'll default to 0 anyway. But just a little nice thing I like to throw in there. All right, so if we go back to Unreal here, there are a few things we need to adjust in our base character BP and our mutant BP. So let's go to base character BP and take a look at our input buffer logic. I have these events called add to input buffer P1 and add to input buffer P2. You can see I haven't done this stuff for P2 yet. We can actually set that up during the video because this might get confusing and it could be good to run through kind of a live demo here. Okay. Anyway, so here in this case, what we were doing in the past is we were on any received button press. Add to input buffer P1 is actually an any key related to the inputs that player 1 has access to. We've gone over this a bunch of times, so I won't go over it, but if you'd like to catch up, I will post the input window here. Might just be a good reminder of what we did to get this set up. So for that, basically anytime we would press a key, it would keep track of the key that was pressed and then retrieve the proper data from it and send it to the add to input buffer function. Right here where we started our journey. Okay. However, we weren't doing anything on released, and if we did, it would cause issues. So instead, what we're doing is we were doing it on press, and we were actually ending it right after that. We weren't doing anything else. So you can see we've changed it quite a bit now. So how it looks here is what we had. You can see released is not hooked up. And this is what we have now. That's quite a bit different. Okay. So, first things first, we need to call the start tracking charge time when an input is pressed. However, we only really care about it if it is found within the charge times map. With that said, it will fail out anyway with the logic we set up, and thus it's not an issue. So whenever any input is pressed, we can just call this function. However, we do have to pass it the correct data. So this is why I think it might be useful to show you how it could work for P2 during a live demo. So let me show you this real quick. Here is what we look like. All right, I'll do this just kind of from scratch, and you can see it here. I'm doing the same thing, the exact same thing that we've done for P1. So don't worry that you can't see P1 right now. It'll make sense in a second. What we need to do is call start tracking charge time. Now, when you do this, you get this structure, charge input structure, which is exactly what it looks like in our code. However, this doesn't help us. We need our individual data. So we can right click and click split struct pin to get access to all the variables in that structure. Okay. And we need to know what input it is that we should be tracking charge time for. Now, we only really care about backward, forward, and crouch, but as I said, it will fail out regardless, so it doesn't matter if there is an input that is not there. And so, the way we actually make this work is we have the key already. We already have this key that determines what button is being pressed. And we have this thing called the input to input type map that we set up quite a few episodes ago. So if you remember that one, input to input type map keeps track of what inputs the user can press to perform an action. This is important because the, let me move this down for you. Because the controls can be changed or they could be played on different devices such as keyboard or controllers. And so we need to know the actual action the player is trying to perform, not the specific input. However, the key can be bound and we can find what the action is. And that's what we're going to do. So we do a find on this map. Okay, I'm not going to make it as nice as the one above, like organizationally. But we're going to take the key and we're going to get the display name. So this will be like, oh, we pressed X on the keyboard, you know, or A on the Xbox controller, whatever it may be. Then we're going to pass this into the find. It's going to do a forced convert here because the types are different. So this key is going to be checked within this map. And then if it finds, you know, the binding for, oh, like X is jump, then I can actually grab the enum and pass that into the input to track input type variable here. The other values don't matter. They're not something we're going to manually be setting based off the key we pressed. It's going to be dictated by the code. So that's all you have to do to actually change the pressed logic here. However, we also have the released logic here, and I will make a reroute node for this to make it look a little bit nicer. But what we do here is we drag off of our find node to determine if it has been found in this map. We can replicate basically this logic here again, but on the release this time. So we can copy our determine input data for buffer call, which, by the way, this is a function that we have in the base character BP, which we have to do updates to. But we can replicate this call and just pass in the correct data. So we need the key from here. The character reference comes from the player2 reference. And the status will be release. Then, instead of start tracking charge time, we actually need to call reset charge time. Right-click on the structure and split it. Then you can pass in the input yet again. What I actually did above was check if this input was found in the input to input type map before doing this logic. Honestly, it doesn't really matter. It actually will fail out, believe it or not, if it's not found. So it won't actually hurt anything. It'll pass in an empty structure, say there's nothing here, and then it will fail out in our code when we do this check to see if the types match, and it won't do anything. It's just a nice little additional thing. You can use this right here. It says true if an item was found. False indicates nothing in the map uses the provided key. So, you know, you can eliminate some entries from getting through and probably speed up your game by having this branch in here. Now that you've seen how I've made it, I am going to delete this and just literally copy it from here. Gonna unselect the elements I don't need. And just like that, good to go. link up all of my options yet again. Doesn't line up exactly where I wanted it, but something like that is good enough. And you can see how this works. So there we go. Now player 1 and player 2 can both perform the start and reset of the charge time. Now the last thing we actually need to do here to get this working is we need to update our determine input data for buffer function. So remember what this function is used for is this will actually go in the input type map, and it will add the input to input buffer. So it'll grab the corresponding value from the key that we give it and perform the correct logic. It'll add the input buffer and be used to track against the commands and stuff. So I've updated it. All the logic that you see here is all the same as it was. I haven't changed any of this. It may look a little bit different organizationally, but it is the same stuff. This stuff right here, this for loop, is completely different. This is just to print the number of frames that I've been holding in input. So you don't actually need to keep that connected, and I'm actually not going to, so that I can move this out of the way and not make it so ugly. And we can cover it a little bit easier. I'll keep this up here in case we want to reconnect it at any point throughout the tutorial, but there you go. These are also just print strings that we had in the past, and they print out different things. We use them to print out the number of frames that have passed and the current frame within the 60 window, so 0 to 59. But nothing that we need for today, and things we've already covered. Okay, so this is the entire function. You can look at it and copy it if you'd like, but I'm going to go over it in full right now. So, we check if the character reference is valid before doing this, of course, just to make sure, because otherwise, if we try and do anything with this character reference, it will crash. So this is very simple. We check if it's valid, and if it is, we go and we check our input to input type map to make sure that we can find this key, just like we did in the event graph in these events right here. Just like we did here. It's the same thing. And so, using the key, using the name, and finding it, if we find that element, we actually add that enum to add input to input buffer. That's all we were doing in the past, is we were adding them here so that we could actually add these things to the buffer and check against the commands. That's all we were doing. But now it's a little bit more complicated. First off, I want to see if not only should we add to the input buffer, but we should add how many frames that input has been held, since our F input info structure does have this now. Remember, we updated it in the header file. And this is why I said we need two of them, ChargeFrames and ChargeTrames. Again, probably should be the same name. But this is because we want to, when we actually pass the F input info into the structure, into the circular array, we want to make sure that we know how many frames it was charged. That way we know if the user has successfully held the input for long enough to perform the command. And so we need to grab that data and send it into the input buffer. And the way I'm opting to do that is I'm taking our charge times array. It's the one we made in code, charge times. I'm going to set up the logic above so you can follow along, because it is a little messy here. It's about as nice as I could make it, but there are just a lot of lines because it is kind of complex. So we take our charge times, we do a for each loop with break. The break is just to speed up some of the time along the way. That we don't have to loop through all of them if we find the right element. Drag off the array element, type break. Then, when we're here, we need to make sure that the input type, remember you keep seeing this equals, the input type equals the other. We need to make sure that this is equal to the value we received from our input to input type map. Basically, the action of this charge time element is equal to the key that we are pressing. We know these are the same. If this is true, bring this into a branch. if this is true, then we want to set the charge frames value from the structure to some sort of value for our input buffer. Now what I do is I make a local variable to store it, because I basically want to use this element right here. If this is true, I want to use this element right here. However, we are in the middle of a loop, and if we do add input to input buffer here, it's going to continuously loop after. So what I do to kind of speed this up a little bit, make it a little bit better performance wise, is I make a local variable. If you scroll down to the bottom of your boxes here, you can see local variables. Click plus local variable. And this is only if you're in a function or event, by the way. So if you're on the event graph, you won't have a local variable. You can just make a regular one if you'd like. And then this local variable is only for this function, and it will be reset every time it leaves this function. So by default, its value is 0, which is what we want. You can drag it onto the screen. I called it charged frame count. You can use a set and pass in the charge frames from this structure instance. Here, so it's a little bit, that way those lines aren't overlapping, just like this, only if it's true. And then if it's true, we want to go ahead and break the for loop. We've already found the element. There's only one, because this will get called for every single button press. So even if you press 2 at the same time, they're going to each have their own function call. So we want to break this. Then, on completed of the loop is when we want to add the input to the input buffer. So this was already here in the prior episode, but we were calling it directly after this is valid check. Whereas now we're doing all this stuff first. I'm going to remove this, since you can now see how it works. But completed should go directly to add input to input buffer. And since we did set this charge frame count local variable when we found the element, you can use it here in the input info charge frames that you need to fill out for the add input to input buffer function. All you do is bring it on the screen, get, and then pass it in. You'll want to make sure this type is an int64 if you're doing it as int64 in the structures, but it's very easy. Once you make a local variable, you change the type. You can search for int, and it'll come up with integer 64. Okay, and at that point, we track the amount of times that inputs have been held. We take that into account in our checking to see if our input buffer matches any of the commands so that we can use an attack. We have our charge times and our elements to look out for charging. And we have our commands factoring in forward and release inputs, as well as charge frames to know how long we have to press and hold an input before being able to perform it. So if we go into this one more time. I took away the print string, so we'll just have to believe it. But you can see if I press back, forward, release, and special, it doesn't actually do anything. Now, if I hold it for a bit and do it, I perform the homing thunderbolt. Just like that. And now also, since we have the reset working, I shouldn't be able to now spam it since I've successfully done it once. And you can see I can't. Even performing the action doesn't make a difference. But if I were to charge it again, I can perform the action. And there you go. That's how you can perform charge attacks in your game. Alright, now there is one alternative that I mentioned earlier in this episode, and this is, remember when we were going over our inputs and the inputs required for commands, I said you'd have to put in a release for every press. Well, to be honest, that's pretty disgusting. I mean, there may be times that you want the user to have to release one button before pressing another to perform a command, just based on the timing of the moves and things. And if so, then that's perfectly fine. Add a release input in there so that the user has to do that. However, us adjusting all of our commands that already exist and don't require that to fit this need is a little bit silly. We could do it a much better way by adding this line here. So, This line, where we reset the correct sequence counter to the number of inputs in the command, it happens if the type is not equal to none, meaning that the user was pressing an input that frame or releasing or holding, whatever it may be. And if we add this to it, the status is not equal to input status release. So basically what this means is that a release input cannot ruin our eligibility to produce a command. So basically, we can release any sort of input we want, and it won't ruin our command loop. It won't say, oh, there's something in the input buffer that shouldn't be here. You can do this for hold as well if you'd like, although I'm not currently using the hold enum. I just use press and release. But by having this check in here, it will only reset the correct sequence counter if the input type, or the input type is filled out, so it's not null or not none, and the status is not released. So mainly, right now, if it's just a press, it will reset it. And so, if you do this, this makes it to where if you go into your character, and you can get rid of it, you can see Homing Thunderbolt now only has 3 elements: backward release, 30 frames, forward press, and special attack press. I've given them 20 frames in between. Again, it's not required that you do that, but just to make it a little bit easier for me, 12 frames is pretty short when I'm trying to show it off and also make sure everything is working correctly. And if you want to delete any of these, like I deleted the forward release, all you do is you click the little arrow of the element and hit delete. And so now if I go and play my game, then when I get in here, you'll notice that everything still works in terms of this. Like I can back up, go forward, press it, and I don't perform the attack because it was too long. Okay, I can also not do it too quickly because I haven't charged it up. But now I can go back, go back, and perform Homing Thunderbolt. And there you go. So I did not have to release it first. It didn't matter. The release gets skipped regardless. So releasing it doesn't throw off the command check. And thus, just by having backward, forward, and special like we had previously, or every episode before this, it still works with the new system, and you can incorporate charge attacks. Alright, and the last thing we have to do is fix up that little issue where you pressing the button one time actually triggers the command several times. So you saw when I was using the Homing Thunderbolt, it was occurring twice, and I explained why that was. Well, I at least explained that we didn't have the functionality to really stop that necessarily yet, and it would be coming in the next episode, and that's true. However, we can put in very simple logic that we'll expand upon and make much, much better in the next episode. But we can do that now to stop these inputs from firing twice, just to make your life a little bit easier, because quite frankly, there's no real need to, if I could actually perform the command, there's no real need to have that in there and, make your game a little wonky in the meantime. So let's add this little bit of logic, we'll fix it up, and then next time we'll make everything a lot smoother by making our system a lot more advanced. So really what's going on here is when we press the input, we call check input buffer for command using type, and it goes in and it triggers the logic. Oh yeah, we've matched these inputs, let's use this command. When you call release, it still goes in and uses the same input buffer with this number of frames, so within 12 frames in this case. And so it says even if the command fails, when it gets called again on release, it checks these frames, and if those attacks, those inputs are within that number of frames, it will execute again. So really, the long solution here and the true solution we will be using is clearing out the used elements of our input buffer, or circular input buffer. But for now, what we can do is basically just check and see if this is a release input when executing a command, and then switch in our character the number of maximum frames to make it a little bit higher to give the player some leniency. Doing this will fix your issue, and you won't have to see those double attacks. So all I've done is in my fighter template character, I've defaulted charge frames to 0 for the F input info. It isn't necessarily required, but just something that I'd like to do because I don't want it to be any other value. Then if I scroll down to my check input buffer for command using type, I just have an enum status here, input status underscore input status that I've added to this function. I've added it to the header file here as well, or the CPP file here as well, excuse me. And then when it gets called, this is only currently called from add input to input buffer, it has this f input info in it. All I do is I take the value that we set right here and pass that along as the input status. So it's that simple. You can go ahead and do that if you'd like. And when you do this, you'll now know what status it was that triggered this function. So it's not exactly the same as this status where we're checking the status of the input that was pressed at that time. It's the status that triggered this function to be called. And if it's a release, we don't want to trigger this logic. Not right now. If we get into something like negative edge, which we will be doing, then of course we may want that. However, for now, just to stop additional bugs from occurring while we're still working on our system, a simple solution is to use this input status, and in the if statement at the bottom where we're checking if we should add the command to the move buffer, so basically the next move to execute, all we need to do is add an additional and check, and input status is not equal to release. So like above where it was checking the individual input, we're checking the entire input that triggered this function call. As an additional note here, now that we are doing this, some issues could arise with the correct sequence counter where it could actually fire multiple times, one for fire, one for release, if pressed at the right time. And since we don't have any way to capture multiple inputs on one frame, then it could go below -1, or it could go to -1 and still try to trigger this logic, which will cause an index out of bounds error and crash. So the two fixes we need in this function to make this work now and make our lives a lot easier before we get into the more advanced input buffer stuff we're going to be updating next episode. You want to check if correct sequence counter is greater than -1 before doing these two statements. Then you want to add this right here to make sure that no moves fire from a release of a key. Okay? So very simple, and I figured I'd show it just so that you don't have a lot of bugs in your program while you're waiting, or if you have to, if you want to take something your own way and you don't want to follow the series directly, no reason for me to leave that in there for you where it's a little bit buggy. Now, last thing I did was increase my number of frames for certain attacks because some of them were trickier than others. For example, Fireball, 12 frames is very difficult to pull off with the system I have set up. So specifically, backward, forward, and light attack is very hard to do within 12 frames on the keyboard because the axes are a little bit weird. When you do, for example, like backward, forward, now that we are incorporating press and release, if I need these both to be press, when you have an axis and I'm going backward and then forward, it's a little bit difficult because they are considered basically, you can't press one without the other. You can't have them both giving values, backward and forward. On a keyboard, because, just like if you had an analog stick, you have one direction. Backward, you move the stick to the left, and you move it to the right. You can't really give it two values at once. And so I switched this up a little bit and just gave it 20 frames in between, so it's much easier to perform in the meantime. However, you can leave it. It won't hurt anything. It's not broken. It'll just be a lot harder to perform until we get in the next fix, where we include multiple inputs on the same frame. But anyway, guys, that's all I wanted to show you. So if I give you one more example before we go with these additional changes, you'll see as I come into the game, I can use all my attacks just like I always could. However, they only fire once, just like they should. I can still use my charge attack, but it only fires once. I can use my fireball, and it only fires once. So those few adjustments will get you sorted until we can perform multiple inputs on one frame, and we can always change them later and remove them if we don't want them. Anyway, guys, that's all I got for you today, so thank you so much for watching. If you enjoyed, please subscribe. Does more for me and the channel than anything else you can do. I just really appreciate it. want to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys so much for everything you do to support this channel, and I really hope you guys are enjoying the series. If you had any issues with this tutorial or any of them, feel free to join the Discord community. It's completely free. Link is in the description, and I'd be happy to assist. I know this one in particular is very confusing, but again, charge times are a very confusing element to add in with all the other input buffer stuff we already had. Alright guys, that's all I got, so thank you so much for watching. Once again, I'm Shawnthebro, and I will see you in the next one. Bye everyone.